Okay guys, welcome back. So far we have discussed our 5 experiments up to exponentially growing signal. Now I'm going to explain you exponentially decaying signal and sine and cos. So very simple, we'll finish it in a very short period because we have another experiments also. Okay. So in exponentially growing signal, we have a point at x equal to exponential of a into n. So a is 1.2, our n values vary from 0 to n minus 1. Whatever the value you are giving, it is taking n minus 1. That is, if we are giving 10, it counts only up to 9 with the distance of 0.1. Okay, I'll give you how the value of n look like. Okay, it's the same way up to here, the same concept. The only line is here x equal to a into a dot cap n, which means a dot cap power n. Okay, so this dot actually represents a power n. These two values are correlate 1 by 1. Okay, I'll tell you the difference, two difference. Okay, just clear here. You take clear all, assign a equal to 1 2 3 4 and then b equal to okay. So now you can see what is a and what is b here. Suppose if I am introducing c as output, a into b, look at the values. Okay, so inner matrix dimension must agree. Okay, we cannot directly multiply the value even though it is having 1 cross 4, that is 1 row and then 4 columns. 1 row and then 4 different columns. Okay, inner dimension must be agree. Okay, for that purpose, right, if I am introducing this dot here, so you will get the value. So each and every element, this 1 will be multiplied with this 5, 2 will be multiplied with this 6, and 3 will be multiplied with 7. So in order to multiply the inner components of matrix, we go for and using this dot, right? In the same way, this a dot cap n. Okay, what is actually cap here? Before that, you just clear all. So a will be 2. A will be 2, and then okay, you can directly specify the values. 2 cap 3. So what is the value here? 2 power 3, 8. Right? Suppose if we have a which contains matrix, right? Just see the A is matrix with the 1 cross 4, row 1, column 4. If you are specifying A cap 3, so the same, it is not square matrix, input must be scalar and a square matrix. So now you have got some idea. So if you put dot here, so you will find the values. So 1 power 3, 2 power 3, 3 power 3 and 4 power 3 is the output displayed here. I hope you gather some information related to this. That is why it is mentioned here, x equal to a dot cap of n. Okay, 0.5 power 0, first value, 0.5 power, next value is what? 0.1. Okay, and so on. Okay, I'll give you the answer. I'm going to display the values of each and every parameter in the left side. Okay, first of all, you have to run this. It is asking me for an input. Put the input value, number of samples 10 here. So you are getting exponentially decaying signal response. So as usual, right, coming to the point here. So we have parameters called a, n and x. First of all, you just clear all and then CLC. Okay, run the value. Okay, now a is 0.5, right? And then n is, just see the value of n. What is actually n? We have in the problem n, which is vary from 0 to, what I have given the n, capital N, 10. It is vary from 0 to 10 with the distance of 0.1. Okay, see, first value is 0, 0.1, 0.2, 0.3, 0.4, 0.5 and so on up to, see here, 10. Okay, so that is the size of n. If you want to know the size of 1 cross 101 matrix, okay, 1 row 101 columns, right? Okay, right. Now the value of x, just clear it, and value of x is, see, what is the value of, what is the, how come it is 1 in the first column? You put the value here. What is the value here? A 0.5 power 0 is the first value, right? So what is the n here? N, the first value of n is 0, a is 0.5, so 0.5 power 0 is 1. Always anything to the power 0 is 1. Okay, right? In the same way, we have got the answer, right? Exponentially decaying signal is over. Now it is close and release the sine signal with the help of control T. But you won't do it this control R and control T in your regular lab sessions, because every time you need to type the program. In order to reduce the timing, I am doing this control R and control T, but don't do it and don't practice in your regular labs. You type the program and then see what is actually happening. Okay, then only you will find some difficulties and then understanding the problems and then troubleshoot the problems, right? So as usual, CLC clear all display, and then we are getting input, and then small n, which has vary from 0 to capital N. Now very simple, sine is the default function. Use this function for small n. I am plotting here, that's all, very simple. So sine 0 is 0, so your signal will be started from 0. See, your signal is started from here. Sine 0 is 0, right? It's a term here. Suppose if I am changing this this plot, save it. So you have edited, so save before run. Can you see the difference? It's analog signal, look like a analog signal. Previously it was discrete signal. Okay, so this is the use of control Z to see the difference. Okay, so now you have got some idea about what is stem and what is plot. Plot is purely for analog signal, which means CT signal, continuous time signal. Stem is for discrete time signal, right? Discrete time means it's a samples, number of sampling based on the sampling theorem, right? So in same way, we have another program called cosine. Release it, save and run. See, your cos 0 is 1, so that it is started from 1 here. So now we have finished our first experiment, generation of signal, okay, successfully. Now I am moving to second signal, second experiment called experiment number 2, linear convolution and then circular convolution. What is meant by linear convolution? It is convolution between two different signals. since we are using matrix, we have to enter the first sequence as a matrix and then second as a matrix also with the same dimension or different dimensions. So we'll start with the same dimension, right? As usual, CLC, clear or close all, getting two different signals, y equivalent to convolution. Convolution is default function used in the available in the MATLAB. Make use of that convolution function for our program. Okay, so with the input two inputs x comma h. Figure is not mandatory to initiate all these rest of the lines. Even if you are not mentioning figure, it will automatically generate the plotting section. Okay. Otherwise, if you put figure 1, okay, and then go for figure 2, right? And this is figure 3. So you'll get three different figures to view our output window, but that is time consuming. We need to get all the figure windows, but instead of doing that, I am going to erase this figure. Okay, disabling this figure by the percentage symbol. Okay, so the concept here is I am giving two different values to the convolution and then I am displaying here. The important point to be noted here is subplot. What is meant by subplot? We have seen what is plot. Here the subplot means that your plotting section is subdivided into some kind of dimensions. Okay, here 3 cross 1. 3 cross 1 matrix with the first position, 3 cross 1 matrix with the second position and third position. Okay, let's see. Let's run this first sequence. See, in a single figure window, you can view the three different plots. That is why we are giving subplot 3, 1, 1. It is giving stem of x. What is x? Input of sequence 1. See the output window here. So this is your x equal to input x. Enter the first one. And what have entered? The 1, 2, 3, 4. 1, 2, 3, 4 is the first, and then second input is 5, 6, 7. Okay, 5, 6, 7, 8, and then your final output window. Okay, so for that subplot 3, 1. So totally we have 3 rows. See, this is 1 row, second row, third row, only 1 column. 3 rows and 1 column is sufficient to represent our 3 different signals in a single figure window, right? Okay. So let's analyze your output window 516, output value 516, 34 and 60, 61, 52, 62. Okay. So as per theory, it is clearly correct. Okay. So okay, circular convolution, it is also very simple one. So we'll take it from our program. See, this is the file I am going to share you when you come to the lab. So it is started from generation of signals. So in your record, as per the principles or instruction, you need to fill up the record with the help of this theory available in the file, in this particular file. Okay, your output files. So you need to take a printout and paste it in the left hand side of the record. our linear program.